Hello students, welcome to the first video of this new playlist. So in this playlist, I will upload the I will discuss each of the questions from the most recent past paper of Physics Unit 1, which is the October 2024 Unit 1 paper. So this is the first video of this playlist. So in this video, we will at first discuss the section A, that is the multiple choice questions of the Physics Unit 1 paper. So let's get started with section A, the first question, the first MCQ basically. Okay, number 1. So here the question is asking which of the following units is equivalent to the watt. Okay, watt is basically the unit for power, right? So power is what? Rate of energy transfer, right? So power is what? Rate of energy transfer, that is energy E over T. So the unit for energy, this is joule, and the unit for time, it is what? Second. So that means joule over second. So this is what? Joule S inverse, which is D. So D is the answer. Fine. Okay, next question 2, the second MCQ. Which row of the following of the table gives two vector quantities? Okay, so vector quantity is basically a quantity which requires both the magnitude and the direction to represent it, right? So which of these row A, B, C, D shows two vector quantities? Okay, the first option is A. So it is what? Acceleration. It's what? Acceleration, it's a vector quantity, we know that, because acceleration, it requires both magnitude and direction. Positive acceleration, negative acceleration. Negative acceleration is what? Deceleration. So acceleration is what? A vector quantity. And then weight. Weight is also a vector quantity because weight is a type of force, and we know that force is a vector quantity. So that means here option A is the answer. B, C, D, none of these are the answers because displacement is a vector, but kinetic energy, energy is what? Scalar. So one of them is vector, one is scalar. So not possible. C, it is what? Strain. Strain is what? It's force per unit cross-sectional area, right? So strain, it's also a scalar quantity. What? Velocity is what? Vector. So one vector, one scalar. Young modulus is what? Young modulus is also a scalar quantity, mass is scalar quantity. So both are scalar, so it's not the answer. So only the possible answer is what? A. Okay. Next, question 3. The displacement time graph for a person running a race is shown. Okay, this is displacement to time graph. We can see it is given. Okay, so this is the displacement to time graph. So which of the following gives the average velocity of the person? Average velocity. So just try to make a relationship with distance time. If the question had asked about the average speed, then what we would consider average speed, we know that what? Average speed, it would be total distance traveled, total distance over what? Total time, right? So for finding average velocity, what we will consider? Velocity, it's a vector quantity. So in that case, it will be total displacement over the total time taken. So total displacement is what? 40. Okay. So they didn't ask for the value. We just need to say, right? So in that case, which of the following gives the average velocity? Okay. A, option A is area between the curve and the x-axis from 0 hours to 4 hours. No, we don't need the area. Gradient of a tangent to the curve at 4 hours. Gradient, yeah, that's fine. Gradient gives you the what? The velocity of a displacement time graph, but at 4 hours it will give you the instantaneous velocity. Okay, so this is not the answer. We need average velocity, right? Which will cover, average velocity will consider the whole journey, not an instant moment. So B is never It's not the answer. Definitely not. Then C. Option C, gradient of a tangent to the curve at 2 hours. It is also saying instantaneous velocity, so not possible. C is not the answer. So only remaining is D. That means displacement at 4 hours divided by a total time of 4 hours. D is the answer. Total displacement over the total time taken. Fine. So that's the answer for question MCQ number 3. Okay, next. Number 4. The photograph shows a cable car hanging from a cable. The cable car is in equilibrium. Equilibrium means what? Resultant force is what? 0 Newton. Okay. So both horizontally, vertically, the resultant force is what? 0 Newton. Okay. So the question is, which of the following forms a Newton's third law pair of forces with the weight of the cable car? With what? Weight of the cable car. What's the Newton's third law pair force for the weight of the cable car? Okay. So Newton's third law pair force. For the Newton's third law pair force, what are the conditions? There should be the two forces. The pair forces should be action reaction force. They should have the same magnitude. They should act opposite to each other, and they should act on different bodies, right? So which of the option meets all of the conditions? Look, first option is A, air resistance acting on the cable car. Air resistance, it's not due to the weight. Weight is basically the force of gravity, the pull of the earth, like the force by which the earth is attracting an object within its field, gravitational field, right? So this is not due to the air resistance, right? Another condition for Newton's third law pair force is what? The two forces should be the cause for each other. Okay, one acts, then the other one acts. Action, if the one acts, then the other one will react. This is what? The cause for each other. So air resistance is not due to the weight. Definitely not. So A is not the answer. B, gravitational pull of the cable car on the earth. Gravitational pull of the cable car on the earth. So the weight of the cable car, it is basically the pull of the pulling force from the earth to the cable car. This is weight. Weight is the force by which the earth is pulling the cable car towards its center, right? So this is the action force. Therefore, the reaction force would be what? The cable car will attract the earth towards itself. Action reaction. Okay? So now you might say it is a kind of weird, right? Like the cable car is attracting, it's pulling the earth. So it might like it might be like what seems to be like unfamiliar or weird, because how the cable car will attract so heavy, so massive earth, right? But yeah, this can happen because the earth is heavy. That's fine. So since it is very heavy, since the earth is very heavy, that's why the earth is not, the effect of this pull, from the cable car, it's very negligible. That's why. Okay, so here in this case B would be the action reaction force, Newton's third law pair force, you can say. Okay, the earth is pulling the cable car, so the cable car is pulling the earth. Simple. C is not the answer. Definitely not, because upthrust of the displaced air acting on the cable car, upthrust is not the cause for weight, so not possible. D, normal contact force of the cable car on the cable. So many of you will think D would be the answer. No, normal contact force of the cable car on the cable, this is basically not due to the weight. Okay, weight is only acting between the earth and the cable car, right? So that's why B is the perfect and the most accurate option for this question. Okay, next question number 5. A box slides down a slope at a constant speed. It is moving at a constant speed. That means it is in equilibrium. Weight and resistive forces both act on the box. Which of the following is a reason why the speed of the box is constant. Okay, so the speed of the box to be constant, if it is to be constant, then the resultant force acting on the box along the plane should be 0 Newton, right? So we will consider that fact. Okay, the option A, it says the component of the weight parallel to the slope is equal. It's what? Equal to the sum of the resistive forces. So this is what exactly the answer A, because it says that the weight, the component of weight that is parallel to the slope, it's acting down the plane, right? So downward weight, it is equal to upward, that is up the plane, the resistive forces. So downward force equals to upward force, resultant force is what? 0 Newton. So A meets the condition, right? So A is the answer. Why not B? B says what? The component of the weight parallel to the slope is greater. So that's why it's not possible. Greater means there it got resultant force, right? If it has resultant force, then the box will rather accelerate. Okay, C is not the answer because the question C says perpendicular component. We don't need to consider perpendicular, right? Because we are considering the movement along the what? Plane, along the slope. So there's no effect, there's no need to consider the perpendicular. Okay, whatever they says here, the component of the weight perpendicular to the slope is equal to the sum of the resistive forces. It doesn't make sense because resistive forces are acting along the slope, but perpendicular, it's what? It's on different dimension, it's on different orientation, right? So C is definitely not. What about D? The component of the weight perpendicular to the slope is greater. It says what? Greater. And also it says what? Perpendicular. Okay, so none of the other three options make sense. Okay, so A is the only acceptable one for question number 5. Okay, next, question 6. In question 6, it says a person stands on a moving staircase. The moving staircase increases the gravitational potential energy GPE of the person by 5000 joule in a time of 42 seconds. The efficiency of the moving staircase is 0.63. Which of the following expressions gives the power input of the moving staircase in watts? Okay, so it increases the GPE, gravitational potential energy, by 5000 joule in a time of 42 seconds. So this is basically the energy what? Output. This is the output energy, because a person is standing on the staircase. Why? Because he wants to go up, right? He wants to go up. That means he wants to gain potential energy. So this is what? Useful energy output. So we can say uh, efficiency uh, it's given, yeah. So efficiency is given as 0.63. So efficiency, it's what? Efficiency, it's power output over power in, right? So we need to find out the power input, so make this as the subject. So power output would be 5000 over 42 over input power is 0.63. So which of the option uh, is similar to that one? Exactly C, right? 5000 over 42 times 0.63, right? If you take 0.63 to the denominator, you will get it will get multiplied with 42. So C is the answer. Fine. Okay, next is question number 7. A student applies a force to stretch a thin metal wire. Which of the following describes the wire at the elastic limit? So elastic limit, till the elastic limit, what we know? Till the elastic limit, material or an object deforms elastically. That means as the applied force is removed, the object will get back to its original dimension, state or condition. Okay, So the option A, it says the wire is elastically deformed. Definitely this one, because till the elastic limit, if you deform a body, it is what? Elastically deforming. So A is the answer. Why not B? B says plastically deformed. Definitely it's not, because till the elastic limit, always the material or the object will get deformed elastically. The wire is at its maximum extension. No, it will be at the maximum extension at the breaking point, right? D, it says the wire snaps. No, at the elastic limit, the wire never snaps. The wire snaps at the what? Breaking point. So A is the only correct answer. Okay. Question number 8. A student uses a wooden bat to hit a stationary ball of mass m. Okay, the stationary ball, its mass is m. Fine. As the bat hits the ball, the momentum of the bat decreases by del p. Okay, the decrease in momentum of the bat, it's del p. The ball then moves with velocity v. The student then uses the bat to hit a stationary ball of mass thrice of m, that is 3 times the mass of the previous ball, right? The momentum of the bat decreases by twice of del p. Okay, which of the following expressions gives the velocity of the ball of mass thrice of m after being hit? Okay, so we need to find, we need to tell here, like, which of the following expression gives the velocity of the ball of the mass 3m after being hit. Okay, so at first consider the first case, this case. In this case, as the bat hits the ball, the momentum of the bat decreases by del p. So consider CLM, conservation law of what? Momentum. So using the law of conservation of momentum, total momentum before impact, it is what? The bat, for the bat, it's what? P before, let's say it's for the bat. Okay, P before for the bat. Okay, this is P before, this is equals, because why I'm not considering momentum of the ball, because it was stationary, so it has no momentum. P before, it is equals to what? Momentum of the bat after impact. Okay, plus what? Plus the mv, the momentum of the ball, right? So P before minus P after, this is what? Del P, right? The momentum of the bat decreases. Yeah, so P before minus, if you take it to the left hand side, you will get del P equals to what? mv. Fine. Okay, we got del P equals to what? mv. Now consider the second scenario. For the second one, same P before of the bat, same equation, let's form the same equation. So P after of the bat plus what? 3mv. Okay, so if you take P after to the left hand side, you will get del P. Okay, it is now twice of del P, so twice of del P equals to what? 3mv. Okay, so now they are asking for the what? Velocity. Okay, so velocity of the ball of mass 3m after being hit. So this is basically v. We need to make v the subject from here. So if you make v the subject from here, you will get what? Twice of del P over what? Thrice of m, right? So okay, let's say this is x, otherwise you will get confused, you will overlap it with the previous v. So let's say this is x. X is what? The velocity of the of the ball with mass 3m after the impact. Okay, so x equals to twice of del P over 3m. So let's make v subject from here. Okay, because the options, all the options you see, these are in terms of v, so we need to represent x in terms of what? V. So v equals to what? Del P over m. So you got the answer now. What? 2 over 3 del 2 over 3v. 2 over 3b. B is the answer, right? Because del p over m, this is what, v. So we can write x equals to what, 2 over 3 b. B is the answer. Done. Question number 8. Next is what? Question number 9. Okay. Two boats A and B are pulling a ship. Each boat is attached to the ship by a rope as shown. Okay, we can see two boats A and B, they are what? Pulling the ship. The force from boat A on the ship is F of A. Force from boat A on the ship, this is F A, and this is F B, right? Force from boat B on the ship, this is F of B. Okay, which of the following expressions gives the forwards component of the total force of the boats on the ship? This is very straightforward question, isn't it? So that would be what? Both horizontal component will be what? Can be related by cos theta, right? So let's say cos 31 degree at first. 31 degree equals to what? Horizontal component F horizontal over FA. So horizontal component is what? F horizontal, it is equals to FA cos 31 degree. Similarly, you will get an exactly similar equation for F of B. Just a bit, you will have difference in the angle, that is 27 degree, and yeah, it will be F of B. Okay, so it is what? Both will have cos 31, F of A cos 31, F of A cos 31 plus F of B cos 27 degree. So C is the answer. Okay, both will have cos. Keep in, you have to be attentive, because here you might get confused, you might do mistake with the angle. Okay, you might consider 27 degree in case in place of 31, so you should be aware of that. Okay, so C is the answer, FA cos 31 degree plus F of B cos 27 degree. That's it. Okay, the last MCQ of this paper, question number 10. Okay, a student puts a piece of wood on top of a cylinder. He stands on the wood with his feet at distances x and y from the cylinder. Okay, so you can see in the figure, it's pretty much clear. The weight of the student is W. The weight of the student is given. The diagram shows the force of each foot acting on the wood. Okay, the wood is horizontal and in equilibrium. The weight of the wood is negligible. The weight of the wood is negligible. Okay, so which of the following expressions is equal to W? W is what? The weight of the student, right? Okay, so in this case we have to consider what? Moments about something. How do we consider the moments? Let's consider moments about this pivot. Okay, because at this contact there is a normal contact force acting, right? So we have to ignore this normal contact force. So let's take moments about this point. Okay, let's consider moments about this point. So if you consider moments about this point, so clockwise moment is what? W minus F times what? Clockwise moment is W minus F times Y equals to what? This is equals to Fx, right? So we need W, Fx. Okay, so what you can do here? Fx over Y. Divide both sides by Y. Okay, so divide both sides by Y. What you will get? So W minus F, okay, W minus F equals to what? Fx over, it will be Fx over what? Y. Okay, so we need W, so that would be what? W equals to Fx over Y plus F. So F plus Fx over Y. Okay, so which one is the answer? Basically Fx over Y plus F. That means A is the correct answer for question number 10, MCQ 10. Okay, so that's the end of section A. From October 2024 Physics Unit 1 paper. Fine.